Continuing our work with vectors, we're going to look at a different set of vectors. These are called unit vectors. And here's what's unique about unit vectors. A vector of length 1 is called a unit vector. We have a horizontal unit vector and we have a vertical unit vector. We normally use the notation of a bold lowercase I to indicate that we're talking about the horizontal vector 1, 0. It has a magnitude of 1 and its direction is that it starts at the origin and goes for a length of 1 directly in the x horizontal direction. The vertical unit vector has components 0, 1, and so it starts at the origin and goes vertically for a magnitude of 1 straight up in the direction along the y-axis. So the unit vector has horizontal component I, vertical component j, and so we use that to denote vectors in a new vector notation. So these vectors are special because any vector can be expressed in terms of them. Let's look at vector A. It has a horizontal component of a sub 1. It has a vertical component of a sub 2. So if I wanted to write this in unit vector notation, it would look like a sub 1i plus a sub 2j. So we can take any vector given to us in component form and we can write it in standard unit vector form. So this is the unit vector form. So we take the horizontal component and we take it as a real number scalar, a coefficient a, and we write it as the coefficient of unit vector I. And then we take the vertical component as a coefficient b and write it as a coefficient to the unit vector j. So these are both the same vector. I can write vector v in component form, a comma b, or I can write it in unit vector form, also called a linear combination. So the vector sum ai plus bj is called a linear combination of the vectors I and j. And so we can write it in vector component form or in linear combination or unit vector form. So you need to be very comfortable with both of those. This is just two separate notations for the same vector v. So let's talk about the unit vector. Let u be the vector with the initial point 2, -5 and the terminal point -1, 3. We can write u as a linear combination of the standard unit vectors I and j as follows. We would, in essence, pick vector u up and put its initial point at the origin. That's what we're doing when we write it in unit vector component form. So the horizontal component would be -3 because it's -1 minus 2. The vertical component would be +8. That's 3 minus a -5. So the vector u can be written as -3i plus 8j. So all we're doing is taking the difference in the horizontal and the difference in the vertical starting from the initial point to the terminal point, just like we did for component form for a vector. And then we take each of those components and write them as a coefficient to unit vector I and unit vector j. Really straightforward. The interesting part is that we can take any vector and find the unit vector. So if you're given a vector in component form and you're asked to find the unit vectors, here is the formula that you're going to use. You take the component form of the vector and you divide by the magnitude of the vector. So here we have vector v. V sub 1 is -2. V sub 2 is +5. So we're going to take that unit vector, -2, 5, and we're going to divide each component by the magnitude of vector v. So remember that's v sub 1 squared plus v sub 2 squared, and we take the square root of that. So we get the square root of 29. So it is the horizontal component over the square root of 29, comma, the vertical component over the square root of 29. And this is the unit vector for vector v. So there's the process that we would use to find the unit vector. We have standard vector operations that we learned in the last lesson on the component form of vectors, and I'm going to show you here that they are the same if you are given a unit vector. So let's say we have u in unit vector form, that's negative 3i plus 8j, and we have vector v in unit vector form, that's 2i minus j, and they want us to find 2u minus 3v. So we're going to take the scalar 2 and we're going to multiply it by both components of vector u, and we're going to take negative 3 and multiply it by both components of vector v. So 2u is going to look like negative 6i plus 16j. Negative 3v is going to look like minus 6i and then plus 3j. You add your horizontal components together, you add your vertical components together, and here is the new vector 2u minus 3v. So really straightforward. Again, just a different form of putting our vectors in, and that's called the unit vector form. So that's it for this lesson. Come to class next time and we'll work on more vectors.